Fractional exponents, also called rational exponents, can be tricky. So I'm going to show you a couple of things with them. Before I do the problem to rewrite using fractional exponents, I'm actually going to first show how this could simplify just with simplifying radicals. So this says to take the cube root. That means to look for numbers in groups of 3 multiplied by themselves sort of 3 times. So what we mean is this: x to the 8th can be thought of as x times 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 x, like that. Which means that we can think of x to the 8th as being x to the 3rd times x to the 3rd times what's left over there, x squared. And sorry, remember that we're going to be taking the cube root, so it should be a 3 right there. Good. So now duplicates in sets of 3. So thinking about the cube root, an example of the cube root of 8 equals 2, because 2 times 2 times 2 equals 8. And the cube root of x to the 3rd equals the cube root of x times x times x, which equals just x on the outside of the radical. So to simplify the cube root of some number multiplied by itself 3 times, that's just that number. So that means that here we could say the cube root of x cubed is x. Then here the cube root of x cubed is again x. And then we're left with x squared under the cube root. So that has to stay there because it didn't have enough duplicates to simplify, if that makes sense. So that means that this is the equivalent of this, where instead of having x to the 8th under the radical, we only have x squared under the radical because x to the 6th worth got out from under the radical when we simplified it. So we can finish this up by saying that x times x on the outside is x squared, and then we still have the cube root of x squared, which is pretty flipping confusing. Anyway, that's a way that we could simplify this with radicals. Now let's do it again, except this time use fractional exponents. Okay, this time this will be a lot faster. Just show how to go from radical to exponent. So you remember the rule that says a to the m over n equals, and then try to remember which number goes here. This is the denominator of that exponent, n. A is the base, and raised to the m power. So here we need to go back in the other direction. So we see the number inside the radical, the 3, rather the index is what this is called. That should be the denominator of our exponent. And there's the base x. And then the numerator of our exponent is the exponent in the original of 8. So this is x to the 8/3. Okay. Now on number 14, something similar, but now we have 8 multiplied by x to the 7th in this group under the radical. So that means that we need to do the cube root of 8, and then we also need to do the cube root of x to the 7th, like that. So the cube root of 8 is 2. And now to do x as a fractional exponent, this 3 goes into the denominator of the exponent, and this 7 exponent as the numerator of the exponent, and x is the base. So putting that all together, this here, the cube root of 8 is 2, so 2 in front, and then x to the 7/3. And I know that this stuff is confusing. That's why we made a video to help you practice it. So we appreciate you going over it and continuing to improve. Keep asking questions.